What's up, everybody? Today we're going to be going over the Algebra 2 review for graphing rational functions for our test tomorrow. Alright, so let's go ahead and dive right in at problem number 1. It says, suppose that x and y vary inversely. Guys, that's a key word there. They vary inversely. And x equals 12 and y equals 4. Write the function that models the inverse variation. Okay, so first off, a key thing to notice here is the word models. Okay, so first off, inverse variation is demonstrated by y equals k over x. If we want to find a model for that situation, we're just really saying find out what k is. Alright, so they've given us enough information that we can find k. So what I'm going to do is I know that x equals 12 when y equals 4. So I'm going to say 4 equals k over 12. All I did was plug in the y I knew and the x I knew. So then I'm going to multiply by 12 on both sides to get k by itself. So that's going to give me 48 equals k. Those cancel, and I'm done. Now all I got to do is plug it back in. Y equals 48 over x. And done. That's all she wrote. This problem is just easy breezy. Okay, so let's start with problem number 2. It says graph y equals 1 over x minus 3 plus 5. Give the domain and range in interval notation. So first off, I don't actually care if you graph this guy by hand. You're more than welcome to use a calculator. But graphing it by hand, if you just pull it off a calculator, is going to look something like this. I'm just thinking for a second. It's going to look something... Oh, nope. 6, 7, just so I have a little space here. And then 5, 3 is going to be right there. Alright, it's going to look a little something like that. I apologize, that's really not one of the better graphs I've ever drawn. Okay, and the reason that is that you should be aware that we obviously have a vertical asymptote happening when x is 3. Because if x was 3, we would get 0 in our denominator. Because if x was 3, we would get 0 in our denominator. So we have a vertical asymptote there. Then we have a vertical asymptote where y is 5, because there will never be a case where y equals 5 for this problem. So we have our two asymptotes, and it wants us to give the domain and the range. Okay? Well, the domain is just all possible x values from left to right. So what's my most left x value? Well, I have an arrow right here pointing to the left. So that would be negative infinity. So now, following this piece of the graph, it stops though when it hits this vertical asymptote. It'll get infinitely closer but never actually touch the vertical asymptote. So that would be a vertical asymptote of 3. Unioned with, because I have another piece of my graph that's happening right here. Okay? And you'll see that this piece will get infinitely close to 3, an x value of 3, but won't ever touch it. So 3. And then it keeps going to the right forever, so that's infinity. And that would be my domain. My range would be, well, I have a arrow pointing down, so at negative infinity, to what's the highest this piece touches. Well, it caps out right here at this horizontal asymptote, which is at y equals 5. So negative infinity to 5, union with, pick up on the other side. This guy is starting at 5 because it'll get infinitely close to this vertical asymptote but never cross it, never touch it. So that's why we use a parentheses. And it'll go from 5 on up forever. So 5 to infinity. And there we go. That's all she wrote. Number 3. What value of x is not included in the domain of the function y equals 1 over x minus 8, and why? So first off, remember that domain is all possible x values. Looking at this function, is there a possible x value that isn't going to work? Yes, there is. It's 8. Okay? Because if x equaled 8, what would you get down here? You get a 0. Can you divide by 0? No. So 8 is not going to be in the domain because it is a vertical asymptote, because if x equals 8, the denominator would equal 0, which isn't possible because I cannot divide by 0. Number 4. What is the equation graph below? So first off, when we're looking at this problem, hopefully you notice, okay, I've shifted my vertical and horizontal asymptote around. Usually, we have a vertical asymptote happening right here on the x-axis, on the y-axis, and usually we have a horizontal asymptote happening right here on the x-axis. Okay? We've shifted our vertical asymptote to the right one So that means we've shifted our entire graph to the right one, and we've shifted our horizontal asymptote up 3. So y equals something, and we're going to talk about that something. Usually it's a 1, but in this problem it's not going to be. Something over x minus 1, because that means shifting right 1, plus 3, because that means shifting up 3. Now, why did I not put a 1 here? Well, look at where we've given you a couple bolded points. Go to the place where the asymptotes intersect one another. Right here. Count up. 1, 2, 3. Remember our a value, that's the value that goes right there, is the distance from our intersection of the horizontal asymptote. It's kind of like rise over run, but we're always going to be running 1. So basically we ask ourselves, how many times do I have to go up to go over a complete 1? Well, that would be 1, 2, 3. So it's just 3. And it's positive because our curves are in the top right and bottom left where we want them. Number 5. Write an equation for the translation of y equals 1 over x that has asymptotes at x equals 7 and y equals 6. So first off, our asymptote is usually at x equals 0 and y equals 0. But if I'm now at x equals 7, that means I've taken a vertical asymptote and shifted it over 7 to the right. So that now should be 1 over x minus 7, because that means right 7. And then y equals 6, well, I went from y equals 0 to y equals 6. That means I took a horizontal asymptote and I shifted it up 6. So I write plus 6. So y equals this. Boom, that's it. It takes 6 students 8 hours to mow the fields at Saginaw High School, SHS. The number of hours varies inversely with the number of students. How long will it take 4 students to mow these fields? So first off, key words. Varies inversely. That should make you think y equals k over x. And it says how long will it take 4 students. So eventually, I want to figure out the amount of time it takes for 4 students to mow the fields. Now, it says the number of hours varies inversely with the number of students. So that means y varies inversely with x. All right? So then we know that if our hours are y and our number of students are x, I can find my constant of variation, that's what k stands for, constant of variation, by simply using this first 2 numbers it gives me, saying 8 equals k over 6. Multiply both sides by 6 to get k by itself, and we get 48 is equal to k. Now that we know k, I can go back in and plug in, and now I have a model for this situation. And specifically, I want to figure out how long it's going to take 4 students. So I can say y equals 48 over 4, so y equals 12. So it will take 4 students 12 hours when it took 6 students only 8 hours. All right, moving on. Number 7. Find the vertical asymptotes, horizontal asymptotes, removable discontinuities, and x-intercepts. Whew, lot to do on this problem. So we want to find our x-intercepts, our holes, our vertical asymptotes, and our removable discontinuities. Nope, I wrote that twice, didn't I? Sorry. Holes and removable discontinuities are the same thing. I want to find my horizontal asymptote. That's what I forgot to put. All right. So first off, first thing I always tell you to find is horizontal asymptote, because that requires no math. It just requires you thinking, is this a Bobo, Boatin, or Betsy situation? Well, look at the degree. The degree is 2. The degree is 2. Since the degrees are equal, bottom equals top, divide the coefficients. All right? So, in other words, we're going to divide the coefficients on those x squares. So what was the coefficient on this x squared right here? It was a 1. What's the coefficient on this x squared right here? It was a 1. So we're going to get y equals 1 over 1, which is just y equals 1. Boom, there's my horizontal asymptote. Now, to find the next 3 things, you have to factor and cancel first. So, let's factor. So, I'm trying to find a good space to factor. We'll do some factoring right here. So, let's factor the numerator. X squared, negative 12x squared. Needs to add to x. 2 numbers that multiply this, but add to this would be 4x and negative 3x. They both have an x in common, 4 and negative 3. So, my numerator can be factored being x plus 4 times x minus 3. Then my denominator, x squared minus 9. So x squared, negative 9, negative 9x squared. Put your 0x out here. 2 numbers that multiply to this but add to this would be 3x and negative 3x. They both have an x in common, 3, negative 3. So this factored to being x plus 3 times x minus 3. Good, so we're done with the factoring. That's all step 1. Step 2 is to cancel. Is there anything I can cancel out? Remember, you can only cancel out factors. Yes, you can cancel out these x minus 3's. So that gives you x plus 4 over x plus 3. Okay, I'm going to scroll down a bit so I have a little bit more space. But to find my wholes, what do? Well, I set what I canceled out equal to 0. So what did I cancel out? I canceled x minus 3. So I set that equal to 0. So x equals 3. Now, wholes are an x and a y value. So I get an x value of 3, and then I need to plug this 3 back into my new equation. So that's going to be 3 plus 4 over 3 plus 3, which is going to give me 7 over 6. So the y value for my whole is 7 over 6. To find your vertical asymptotes, you set your remaining denominator equal to 0. So x plus 3 equals 0. So x equals negative 3. So my vertical asymptote is x equals negative 3. To find your x-intercepts, you set your remaining numerator equal to 0. So you get x equals negative 4. And you know that every time I cross the x-axis, the y value is 0. And we're done. Alright guys, thanks for watching this. If you have any questions at all, send me a remind. Send me an email. Make sure you get in contact with me. Tomorrow, which is the 18th of April, 2019, I will be here at about 8:20. So, and I have duty from 8:30 to 8:50. So, if you need my help, I only got about 10 minutes of tutoring in the morning. I will be here about 15 minutes tonight, maybe 20, because I have to go pick up my kid. All right, guys. Again, thank you guys for watching. Please let me know if you have any questions, anything at all. Have a wonderful day.